Thank you for everyone who's joined. This is part of our Temple webinar series for 2021, where we're going to be talking about 7 acoustic considerations when developing residential buildings. I'm Nigel Burton. I'm a director in our acoustics group at Temple Group. Going to just go through a quick introduction to Temple itself, then the main feature of the bits that I'm going to talk around. And then we'll have some questions at the end, and I'll have a trailer for the next one of these, which is in a month's time. So just a bit of housekeeping. If we can hold questions to the end, we'll have a session on questions there, and I can always go back to old slides if we need to. You can raise your hand on Teams, or if you'd prefer, you can drop a question in the comments box. Or I'm quite happy to take questions if you want to unmute or come on camera at the end and ask questions that way. That will be fine. And I think you've already started the recording, haven't you, Carla? I can see that in the corner there.
I have, yeah.
Great. So just a bit around Temple's. Temple's one of the UK's leading independent infrastructure and property consultancies specialising in environment, ecology, planning and sustainability. We deliver specialist advice to infrastructure, public sector and urban regeneration sector clients. And you'll see from the box in the middle the types of disciplines that we cover, obviously with the most important in the middle highlighted and underlined there. And our vision is putting communities and the environment at the heart of decision making. So, main feature, 7 acoustic considerations when developing residential buildings. I make no apologies, there's very little technical detail in here, so apologies Telly if you were expecting something very, very acoustical. It's got, I don't believe I've got any dBs in the presentation whatsoever, but I do mention a couple of BSs in passing, but it's really just around the things that we should generally be thinking about when we're developing residential buildings. So number 1, external noise levels. So thinking about how noisy is your site, how might this affect the ventilation and cooling strategies for the homes, and will noise levels in gardens and or balconies be excessive? So best way to look at this is early noise surveying helps us to consider the design options such as things like screening from buildings, orientation of the layouts of the developments. Natural ventilation and cooling can be a challenge on noisy sites, but it doesn't necessarily have to be impossible. And again, that orientation and screening, thinking the more options we've got to look at acoustically, the better really. And consideration of orientation of gardens and or balconies for helps reduce noise levels in those spaces. On particularly noisy sites, we might look at things like winter gardens on apartments, or an alternative is to find an alternative relatively quiet space. So if we can't achieve the types of noise levels that we'd like to achieve in external amenity space, we could look at a quiet area on the site somewhere else, or a relatively quiet park nearby might be another option. So just some guidance examples. BS 8233 gives noise criteria for internal noise levels for things like bedrooms and living rooms, and also gives some guidance on the types of noise levels that we should be expecting in external amenity spaces. Pro-PG and the AVO guide, which is the acoustics, ventilation and overheating guide, gives some really good advice on those things as well. And a lot of that sort of background information comes from the World Health Organization documents. So just a quick case study. This was Lefebvre Walk, which I worked on back in 2004. So if you can see, this is the A12. Can you see my, hopefully you can see my cursor there. This is the Lefebvre Walk development here. And because this was so noisy, this barrier block was built along the length of the development. If I click through, this shows you the road, this A12 here, and this shows the barrier block built all the way along from the roadside, but also on the development side. So as you'll see, there's some quite small windows here, which were actually deep voided, double glazed windows. And the design was effectively so you would orientate the noise sensitive rooms were on the, go back there, noise sensitive rooms were on this side of the building, and on the back were things like bathrooms, kitchens and hallways and stairs were on the back, so they didn't need to be quite as quiet. And it just struck me as it was before Pro PG brought in good acoustic design, but just strikes me as a pretty good example of good acoustic design where this wall is part of the development, so it isn't an additional cost, but it's screening the rest of the development from the noisy road. And this is how it looks today on Google Maps. Next thing to think about is vibration and ground-borne noise. So is your site close to any potential sources of vibration, such as railway lines? If vibration is a potential concern, an early preliminary vibration survey can confirm whether a more detailed vibration assessment is required, and it can just help to scope that in or scope it out, which is useful. So next case study is another project I worked on, which is St Pancras Chambers. This is how it looked in 1868. That's not when I worked on it, but I worked on it between 2004 and 2010-11, when it was being refurbished as private residential and a Marriott hotel. Now the main building itself has Thameslink trains running underneath it, which did squeal a bit. I think there used to be a Thameslink curve. I'm not sure if that's been taken out now. But if you look here, there's a blank space which was filled in with new hotel rooms, a new bank of hotel rooms, which were actually isolated, and some were even cantilevered across and hung below the isolation itself, which was quite clever stuff. But it just showed that you can reduce the vibration and ground-borne noise levels by isolating parts, either buildings entirely or parts of buildings. Next thing, internal airborne sound insulation. So thinking about the appropriate specification of separating walls and floors, and how will junctions be detailed to minimise noise transmission. So consideration of performance standards that we're going to use, so it might just be building regulations which had its own sound insulation standards for these, or might be enhancements for things like Code for Sustainable Homes, Home Quality Mark or BREEAM have all got credits associated with improvements on the building regs. Consideration of the types of construction that might be used, so it could be masonry or lightweight constructions, or a mix of the two. Whether or not the building is going to be sound insulation tested at the end of the build, or we're going to use robust details. So robust details are effectively a standard set of constructions that have been tested previously, so they know that they pass with flying colours. I tend not to see so many robust details that used these days. I think partly because you have to use a full set of robust details, but it's certainly something to consider to avoid the need for sound insulation testing on completion. Consideration of interactions at junctions, penetrations for services. Bear in mind is back-to-back electrical sockets where they're on either side of a partition, so that should be avoided. There are ways that can be treated, but it's best avoided, to be honest. And just thinking around noise from non-residential areas, so commercial space, lifts, plant rooms, those sorts of areas. Number 4, internal impact sound insulation. So how will footfall noise be controlled? Typically, this will be dealt with resilience within the floor layer from above, and or independence of the ceiling below. So this just gives you some examples from approved document E, which is part of the building regs, so part E of the building regs. So floor type 1, I think this has to be an integrated soft floor covering, so it can't be removed as part of a later fit out. I'm not a particular fan of floor type 1. I think things like floor type 2 and floor type 3. So in terms of floor type 2, we've got the resilient layer under a floating layer above this concrete floor, and then the ceiling doesn't have to do as much below. And then we've got a platform floor. So in floor type 3, the ceiling is effectively independent from the floor above. So that's what gives some resilience between the two. So this is another case study. This is one that we're working on at the moment. So this is Middlesex Annex. So this is the University of College London Hospital Charity are redeveloping this site in Cleveland Street, W1. So that tall tower behind there is Telecom Tower. So that gives you an idea. It's around the back of Tottenham Court Road. The scheme includes around 70% of affordable housing and around 7,000 square metres of commercial space, including clinical space on the ground floor, in the basement. So this building here is a Grade 2 listed 19th century workhouse, which was Charles Dickens' inspiration for Oliver Twist. And there's also a north house, which you can't quite see behind, and what I think they've cut out here in order to show it on the image. There's also a south house as well, which are heritage buildings. So those are refurbishment areas, so that proves its own challenges. And then this is obviously the new build areas itself. And it's great to see old buildings just coming back online, really. So reverberation control is the next thing for us to think about. So consideration of selection of surface finishes to optimize acoustics within spaces. This is essential in some areas and desirable in other areas. So it's essential in communal areas which have, for apartments, which are directly accessed from those communal areas. So things like stairwells and entrances where you don't have doors straight off into the apartments, you don't need to control it for those, but it's more corridors and things that are next to the front door of an apartment. And this is typically dealt with an acoustically absorbing ceiling. So things like perforated plasterboard or mineral fibre tiles, those sorts of things. There's also a fashion for hard surfaces within dwellings, so consideration of how occupants can introduce acoustic absorption into their own living spaces. I find this room I'm in now doesn't sound too bad to me, but I've heard recordings in the past and it's quite boomy. I've got a hard laminated floor, and I've not really got any soft furnishings around the space. So just consideration of how you can make spaces a bit softer, acoustically softer, I think is useful. Next one is internal building services noise. So are spaces mechanically ventilated or cooled? If so, how will these systems be controlled for noise? So the first thing to consider is selecting appropriate noise criteria early in the design and communicating that with the design team. And critical is discussion with building services engineers to understand their proposed solutions, the types of systems they're going to use, just to make sure there's that interaction between the two design partners, if you like, of those systems. As well as noise from the systems themselves, we also need to consider how those systems will be routed. So it's things like minimising ductwork through critical walls, if possible, and it goes back to that earlier point, location of plant rooms, location of lifts, having lift shafts next to apartments it's just something that makes it's another acoustic challenge. So if they can be located away from apartments and particularly sensitive spaces within apartments, that can help. And finally, external building services noise. So how will noise from our externally mounted plant be controlled to minimise disturbance to neighbours? This is typically controlled in line with BS 4142 methods for assessing industrial and commercial sound, and it's relative to the existing background noise levels in the area, with allowances for characters such as tonality, impulsivity, and things like that. So the plant rating sound, which takes into account those characters, if it's equal to the existing background sound level in the area at the time, it's considered to be low impact. But there will be some variation in local authority interpretation of how BS 4142 should be adopted. So that's just something that it's worth speaking to the local authority early on. As for 6, discussion with building services engineers to understand their proposed solutions, where they're going to have plant, where the nearest noise sensitive neighbours are going to be, is critical to the success of that. And early noise surveying helps with preliminary plant selections. It's going to need to be a noise survey anyway. So it's really, the earlier we can get that, the earlier we can sense check. Are we going to have an issue with this? Do we need to look at alternatives? Quieter plant? Do we need to look at mitigations such as attenuation or screening, those sorts of things? And then just so in summary, I've gone through that a lot quicker than I expected to, so we can go back over anything if we want to. In summary, it's just consideration of things like external noise level, vibration and ground-borne noise, internal airborne sound insulation, internal impact sound insulation, reverberation control, internal building services noise, and external building services noise. So there's a lot of things to think about, but early acoustic involvement generally leads to better acoustic outcomes and means that we aren't seen as adding cost to projects. If we can get involved early, we can kind of steer things in the right way rather than having to solve problems later on. And noise and vibration don't have to be showstoppers if they're given early consideration. So that was all from me. Since Notting Hill's director Roger Mitchell passed away last week, I thought I'd add this slide in. But are there any questions?
I don't know. I'll ask you a general question.
Go on,
yeah, so I mean, this is a rallying call to get acousticians early in the process. You know, in your involvement, because you know you are in a multidisciplinary, and I don't know if you have a planning department, probably not. But you guys, you know, other areas, other disciplines in Temple get pulled in earlier. What do you think is the reason why acousticians are not brought in at an early stage and only usually at planning when things layouts have been decided? Apart from that. That great example you gave us with that massive wall.
Yeah,
that was brilliant. Yeah, you were brought in really early, but that is very rare. I know you did it back in 2004, but even now, it's really rare. Usually we are brought in. Yeah. So what do you think? You know, what do you think is stopping people?
I think it depends. I see it, Telly, as you particularly get things where noise might not, if it's particularly noisy, so that Lefebvre Walk was an example where everybody could recognise early on that noise was going to be an issue, so I think it got brought in then. I think if noise isn't seen as a really big issue, on a lot of sites in London, people won't consider, oh, well, it's just like anywhere else, but obviously as standards have increased, really, we will kind of get perhaps forgotten about a bit. But if we can, as you know, if we can get involved earlier, we can just look at things and say, well, what about putting this there? What about putting that there? I know on some of the schools that I've worked on in the past, it was becoming, I think if architects or design teams had been burnt on projects in the past from an acoustic perspective, they might be more aware of the issues. So on a few that I worked on in London Borough of, I think it was Newham or Barking, they had very noisy roads where they were going to put new schools, and they thought about it and put, the acoustically sensitive but mechanically ventilated spaces next to the road so we could treat those, and then the spaces they wanted to naturally ventilate on the back, so they were being screened from the road and were further away from the road. So there was certainly thought had gone into that even before we'd got involved, but we could finesse it. It's more of an issue, as you say, if something's completely finished in terms of layouts and how it's going to be designed for a development, and then we kind of come in and have to add problems or solve problems that may not have been there if we'd been involved a bit earlier on.
Yeah, okay, thanks. And what, so now the common time where we are called in is when the layout is all done, and you might have sensitive windows near a noise source. But there is also a push for natural ventilation nowadays. The AVO guide talks about overheating. ProPG really talks about having windows open all the time. So what are your thoughts in terms of the mismatch of developers not getting the acoustician on board, and now us telling them, or everybody telling them, that they shouldn't rely on closed windows all the time?
Yeah. It's a tricky one, particularly with things like the AVO guide. But I think, as you know, I think historically, if you looked at the ventilation report, it would say throw the windows open. If you look at an acoustic report, it would say close all the windows. And as long as you read the two reports separately, there wasn't an issue. So I think it's good that it's been recognised that, well, we need to look at everything holistically and at the same time. I think the more we start trying to address the issues of particularly overheating with windows open in noisier environments, the more solutions we will see evidence of more solutions coming through, and which ones work well, which ones don't work as well. So things like louvered doors, things like that, I think can work. But there will be a push, I think, in some areas where it's comfort cooling might be required. But again, it's just the earlier you can look at those things and consider what the potential issues could be, both from an overheating perspective and from a cooling from an acoustic perspective, the better, really. Yeah.
We have an inner city area in Sydney called Marrickville, which has aircraft noise, road traffic noise, and industrial and light industrial uses nearby residential uses. And at the moment, some of those industrial uses are changing over to become residential developments. In that council area, the developer is required to prepare a noise information pack for future purchases to outline the noise impacts on the site, and that's required to be provided with the contract of sale, so that anyone moving into the area is well aware of the noise impacts for that particular site. And I think that's one way that they've gotten around that planning tight point that you want to allow for changes of uses over time, but you also want to protect the people who are purchasing and give them an understanding of what they're buying. So I thought that was an interesting thing that had come through from the council side to address that concern.
Is that common, Hilary? Is that something you've heard about elsewhere? Or?
No, it's the only one that I know of in the Sydney Basin. I mean, all of the councils where there's aircraft noise, they all require aircraft noise assessments for any residential uses and, well, any commercial uses as well, to make sure that your building shell is adequate. But it's only the Inner West Council, and which predominantly is Marrickville, where this comes up.
Yeah, that's an interesting. Yeah, so I've heard of it before. I mean, an example we have in the UK is if you've got historic buildings and you can't achieve the sound insulation requirements of approved document E because you can't knock too much out, if you can't do certain things to the building itself. I think the requirement is you have to get as close to the requirements as possible, and then you have to put a certificate up on the wall saying what the sound insulation standards are that have been achieved.
Okay.
Yeah.
That's interesting. And we're also having difficulty at the moment with natural ventilation in noise affected areas, and you know, a big bulky building is great along the roadside, but you need the planning authority to come to some rooms being mechanically ventilated, so that you have that building mass to give that screening. It's just getting them to come to the party can be a little bit hard at times.
Yeah, we've got the thing. So I think it's still in the London Mayor's documents, which is a push against things like comfort cooling for environmental reasons. But then that then can make it quite challenging to then have new residential if you're trying to achieve the appropriate internal noise levels that we're looking for in particularly noisy areas.
Yeah, so we have City of Sydney Council has particular internal noise goals that are nominated in their planning documents, but then separately they also there's a planning, a state level document, the Apartment Design Guide, which talks about natural ventilation. They were designed to be separate documents, and that they never intended that natural ventilation was going to be the only solution, but the council has decided that they want it. And so it's yeah, we're having a bit of a fun time at the moment addressing that.
Yeah, so I'm guessing you probably have a lot of comfort cooling, but not necessarily mechanical ventilation. Is that right? Yeah,
so yeah, we have, yeah, exactly. Yeah. A lot of people will have split systems on the wall, so there's no air coming in or out of the facade. Yeah. That's really common, but most buildings, by and large, will be naturally ventilated unless there's aircraft noise or something like that. Yeah. City of Sydney doesn't have that many areas that are aircraft noise affected. It's mostly road traffic noise, and the council keeps harping on about wanting to have a vibrant city and lots of people living in town and having the hubbub. But that doesn't seem to have come down into the council level decision makers. Anyway, it's just another reason why getting your consultants on board early on is so helpful, so that you can do as much with careful siting and design and placement of those ancillary rooms on the noise affected facade, because no one really cares if your laundry has mechanical ventilation. And then having your bedrooms shielded. So yeah, absolutely right with all of that.
I think it's one of those things of I've been criticised is probably a bit too strong in the past of acoustics is costing us so much on this project, but it's when you've been brought in after everything else has been designed.
Yeah.
And then you're having to, the cost is, well, you've created this problem by orientation, by this, that, or the other, which we now have to put in super duper glazing or mechanical ventilation, which if we'd been involved a bit earlier on, even if it's just to kind of blue sky things and say, well, what if you put that there? What if you put this there? Yeah.
Yeah. Those options are taken away. It makes it hard.
Yeah. Any other questions, or should we leave it there? Stunned silence.
Yeah, let's leave it there. Yeah, good one.
Thanks, Terry. So just a trailer for our next webinar is on Thursday, the 21st of October. And that's going to be what can we do, air quality, carbon and sustainability in an era of climate change, climate crisis. So thanks for joining us today.
Okay, thank you.